Hello everyone, welcome back. Now in today's lesson, what we're going to go through are miscellaneous equations and graphs. So what this exercise is about is going to give you a summary of all the graphs that you've learned so far in this chapter, and it will test you on that. And it will mainly test you to find the equations of graph. So it's actually more challenging than just sketching the graph, because I believe sketching the graph is easier than finding the equation of the graph. So let's get started. So I'm just going to go through the types of graphs that you should be familiar with. Just a quick summary. So for all the graphs you've learned in this chapter, it is important that you can identify different types of graphs from the equations and determine a possible equation of a given graph. So the first step I expect you to already know. The second one is more challenging and it takes a bit of practice. Now, information about the features of the graphs can be obtained from the equation. You need to know how to find these features from the equation before attempting the next exercise. So now with a straight line, I kind of expect you to know this. This is a straight line with an x and y, the intercept. You need to know the slope, and you need to know if it's a horizontal or vertical line. So a horizontal line could be something like y is equal to 3. That's a horizontal line. Vertical line is something like x equals to 3. Okay. Now with the parabola, you should know how to find the x and y, the intercepts. You should know how to find the vertex. So remember the x equals minus b on 2a. Axis of symmetry, concavity. So concavity means if the parabola looks like this, it's concave up. Or you can say if a is greater than 0, concave up. A is less than 0, that's concave down. Now for hyperbolas, now not all of them will have x and y, the intercepts. So for example, in this one, there's no x and y intercept. But in this one, you can see there's an x-intercept here. And this one has no y-intercept. You need to know the equations of the asymptotes. So every hyperbola has two equations of asymptotes, the horizontal one and the vertical one. So in this case, there's a vertical one and there's also a horizontal one. The orientation of a hyperbola. So if you have a hyperbola that looks something like this compared to a hyperbola that looks something like this, right? So the first hyperbola should be in quadrant 1 and 3. Because it's positive. The second hyperbola, which is negative, it should be in quadrant 2 and 4. Right? Alright. Let's see what the next graph is. Circles. Alright, circles you should be familiar with. Circles should be in the form of, say, x. So the basic circles, x squared plus y squared equals to r squared. Or the ones that's being shifted, x minus h squared plus y minus k squared equals to r squared, right? And the part that students tend to struggle with is when they need to complete the square to find the center and radius of a circle. So make sure you revise on that if you're a bit lost. Cubic curves. So these are the basic cubic curves, not the fancy ones that I'm talking about. But these are just cubic curves, whether if it's increasing, that looks like this, or if it's decreasing, that looks like that. So this will be something like y equals to minus the x cubed, and this will be y equals to the x cubed, right? The exponentials, I don't need to explain too much about these. These are pretty obvious. They look like exponentials, and they also have a horizontal asymptote. So every exponential has a horizontal asymptote. Now, when they say, is it increasing or decreasing, all you have to pay attention to is you look at the diagram from the left to the right. You always look from left to right. So if it's going down from left to right, it's decreasing. If it's going up from left to right, it's increasing. So this cubic curve is going up from left to right, it's increasing. This cubic curve is going down from left to right, it's decreasing, right? So if it looks like it's decreasing, it most likely is. Y equals ax to the n. So with these kind of graphs, you just have to pay attention to what the n is. So if you have y is equal to ax to the n, if n is odd, this number is odd, then it will just look like a parabola. If it's even, it will look like a parabola. If it's odd, then it will look like a cubic curve. Okay, so that's that. And in terms of translation, so that's just basically how a graph can shift up, down, left, or right. So terms in an equation indicates that the curve has been formed by translating a simpler curve in either vertical or horizontal direction. If you have something in this form, y equals to ax cubed plus d, that means, so if the number is on the outside, it means it's a shift either up or down. But say if the number is on the inside, so say if a equals to y equals a, x minus r, you can see how the I is on the inside of the bracket rather than the outside. Then this is a horizontal shift. So this is shifting to the right, the r units. Graphs that contain even power x have an axis of symmetry. If the y-axis is an axis of symmetry, then the equation will be identical when x is replaced by minus x. Okay, so you don't have to worry too much about this. But basically, if a graph has an even power, so for example, you have y is equal to x squared, y is equal to x, I don't know, minus 1 to the power 4. These are graphs with an even power. They all have an axis of symmetry. And do you know why? Because they're all parabola looking. So of course you'll have an axis of symmetry if it's parabola looking. And circles also have an axis of symmetry because circles, well, they have an infinite number of symmetries. So of course you'll have an axis of symmetry. All right, so let's just go through some of these questions. I'm just going to pick some random ones just to make sure I can cover them. So 7.14, question 1. Now it says, from the list of equations given below, choose one that is a straight line. All right, that should be pretty easy. Come on. So you have something like y is equal to x minus 4. That's a straight line. Y equals to 4. Straight line. Hyperbola. Hyperbola basically means anything that has an x at the bottom. So this, O or P. Right. Parabola, anything with the x squared. So B. Okay, A is not a parabola because it's also got a y squared because that's a circle. All right, so that's question 1. I'm just going to copy this because we need to know this for the next question. Just give me a sec. Okay. Now let's look at question 2. Question 2 says, select the equation from the list in question 1 that matches each of the graphs below. Okay, so as you can see, this is a blue question, so it's a little bit more advanced because now you have to select the equation. Okay, so here it says, okay, so what can A be? Well, A is obviously a circle because it's x squared plus y squared, so it can only be I or P, right? Now, because we know it's x squared plus y squared, the center has to be at the origin, so it has to be I. All right, let's pick another one. Let's pick O. So y is equal to minus 1 on x plus 4. So this is a hyperbola that's turned upside down, shifted up 4 units. So let's look at which one are the hyperbolas. So it can either be G or it can be N, right? Or it can be L. But because this is shifted up 4 units, that means what? The y-intercept needs to be 4, right? So from G, L, and N, which one has a y-intercept of 4? Well, I'll leave the answer to you, but it should be pretty obvious. Oh, actually, there's also D, but it doesn't matter because from D, G, L, and N, there's only one of them that has a y-intercept of 4. All right, let's pick another one. Let's see. Let's pick N. Y is equal to 4 to the minus x plus 1. So this is an exponential that's shifted up 1 unit. But remember, because it's a minus x, then the exponential should not look like this. It should look like that, right? And it's shifted up 1 unit. So let's see which exponential looks like that. So there's B is an exponential, J is an exponential. Is that it? Okay, I think it's probably J just because it looks closer to the actual graph. But I think that neither B and J are technically correct, but J is the closer looking one, so I'm going to pick J. Okay, let's take a look at another question. So say K, okay, y equals to x to the 4. Now, this is basically a parabola looking shape, but slightly more fat than a normal y equals x squared. So which one can it be? So it has to be at the origin. So it's either H. Actually, it can only be H, all right? Because this is the only parabola looking shape that's at the origin. All right, so I've gone through some examples in 2, so hopefully that's fine. Now I'm going to do question 3. And question 3 is pretty much the reason why I made this video, because these are the most difficult questions. They're difficult because they ask you to find the equation yourself, rather than giving you equations to pick from. So let's just pick a few of them. So let's just have a go at 3C, okay? So 3C. So as you can see, this is a parabola that's moved right 2 units and up 2 units, right? So we can write this. You can write it like this. Y is equal to, so it's shifted right 2 units, so x minus 2 squared. And then it's shifted up 2 units, so plus 2. Now remember, you also need to put an a here, okay? Because there's different types of parabolas that can be shifted right 2 units and shifted up 2 units. All right, so you can just apply the same principle as how I did the other questions in the past. Find a point on the graph and substitute it in. So you can substitute this point in, right? So the y-intercept. So sub 0, 6 into the equation. So then you get what? So 6 becomes y, a 0 minus 2 squared plus 2. So then what should you get? 6 is equal to a times 4 plus 2. So then you get what? So then 4, you take away 2 from both sides, is equal to 4a. A equals to 1. So once you find the a, then you sub the a back in. So therefore, y is equal to, now because it's a 1, I don't need to write the 1. Okay, so I can just write x minus 2 squared plus 2. So that's C for you. Okay, so now let's look at another example. So let's just take a look at 4D. Okay, 3D. So 3D, you have to find the equation of this graph, and this is a pretty challenging question because you need to know how the equations of each exponentials work. So we know that y is equal to a to the, say, x. That will look something like this, right? So what kind of equation will have to look like that? So you can have, so say y is equal to a to the minus x. What does that look like? Well, y to the minus x looks like this, right? Okay, so then how do you get the shape to look like that? Now, if we turn this graph, y to the a to the minus x, the upside down, then what would that look like? Y equals minus a to the minus x. So that's this graph turned upside down. Now, if we turn this graph the upside down, then we do have something that kind of has that shape, right? So the only way to get to this is if we shift this graph up, say, k units. Okay, so then to get a graph like this, your starting equation will need to be y is equal to minus a to the minus x plus k. And this is pretty tough because the reason it's tough is because you have an a to work with and you have a k to work with. So let's just sub in one of the points. And we know one of the points is the y-intercept. So then what we can do is sub 0, 2 into this equation, right? So let's just sub 0, 2 and see what we get. So when y is equal to 2, x equals to 0. So minus a to the minus 0. So that's just 0 plus k. And remember, anything to the power of 0 is 1. So therefore, 2 is equal to minus 1 plus k. Remember, it's minus a to the 0. So that's equal to minus 1. A lot of students would think this is equal to 1, which is incorrect. Now, if minus 2 equals to minus 2 equals to minus 1 plus k, what does k equal to? K equals to 3. Right? You add 1 to both sides. So now you can sub the value of k into this equation. So you get y is equal to minus a to the minus x plus 3. However, there's still another variable that we need to work out, and that is the a. So how do we work out the a? Well, we can sub another point in. So let's see, what other point can we use? So we can use minus 1 and 1, right? So there's that point there, which we can use. So I'm just going to do sub minus 1 and 1 in. Because the other points, they don't look like whole numbers to me. So I'm just comfortable subbing in with whole numbers, just to make it easier. So then 1 is equal to minus a to the minus 1, which equals to 1 plus 3. So 1 equals to minus a plus 3. So what does a equal to? Well, if we want to solve it, take away 3 from both sides. Minus 2 equals to minus a. A is equal to 2. So now we figured out the a, so we can say therefore y is equal to minus 2 to the minus x plus 3. Right. So question 3D is actually a pretty challenging question. So if you struggle with this, it's okay. Don't feel too stressed, as this is a pretty tough question, but make sure you understand most of the steps that I take. Right. Now let's take a look at another question. So let's say g, for example. Okay, so g is a lot easier because there's not that many variables we have to deal with. But we know that this is a cubic curve, right? That's flipped. It's a cubic curve that's turned upside down, because we know that the normal cubic curves will look something like this, right? So this is an upside down cubic curve, and it's also shifted down 4 units. So we can write this as y is equal to minus x cubed minus, say, d, right? Okay, so to do this, you just have to do one more thing. Okay, so first of all, how many units? Actually, I'm gonna restart this question, because for cubic curves, remember you also need to have the a. So it's actually minus a x cubed minus d, right? Now, how many units is the graph shifted down by? It's shifted down by 4 units. So we can write this as y is equal to minus a x cubed minus 4. Right, and the next step we need to do is find out what the a is. To find out what the a is, we just substitute one of the points. Now, we can't sub in 0 minus 4, because if you sub it in, you won't actually get the value of a. You have to sub in another point. So let's see. So you can sub in the point 1 and minus 5, right? Because that point looks like a whole number. So we can sub 1 minus 5 in. So let's see what we get. Minus 5 is equal to minus a times 1 cubed minus 4. Minus 5 equals to minus a minus 4. So then we have what? We add 4 to both sides. Minus 1 is equal to minus a, so a equals to 1. Right? So then a is equal to 1. So then we just sub the value of a back into the equation. Y is equal to minus 1x cubed, which is minus x cubed minus 4. Alright, so that's g. Let's take a look at another one. So say k, for example. So just remember, with these questions, the hard part is actually the first step, where you write it into the general form before you sub in the point. So okay, we can write this as y is equal to a x minus the first x-intercept. So x minus minus 2, which is x plus 2. Next one is the 0. So x minus 0, which is the same as x. Third one is the intercept is 1. So we write x minus 1. Okay. So we can just try to make this look a bit nicer. Ax, x plus 2, x minus 1. Now to solve for a, you got to substitute a point in. So I'm just going to pick, say, 2 and 6, right? So you can see that point, it goes to that point. So sub 2, 6 in. So then what we should be left with is 6 is equal to, so a times 2 is 2a. 2 plus 2, 2 minus 1. So what does this equal to? 6 is equal to 2a times, now this is 4 times 1, which is 4. Right? 4 times 1, yep. So then 6 is equal to 8a. Right. So then a is equal to 6 over 8, which equals to 3 over 4. And now you have to sub the equation back in, right? So then you get y is equal to 3/4 x, x plus 2, x minus 1. Right, so hopefully that was not too bad. Let's take a look at another question. Let's say question the O. Okay. So let's take a look at question O. So for this question, we know it's a hyperbola. So we can write this as, so think about it. This is a hyperbola that's in the second and fourth quadrant. So you should start with y equals to minus k over x. Right? And because it's shifted up 1 unit, so it's shifted up 1 unit, so you can write plus 1. Right? And now you just have to solve for k. So how do you solve for k? You substitute a point on the hyperbola. So let's see, it goes through 4, 0, right? So sub 4, 0 in and solve for k. So in this case, 0 is equal to minus k over 4 plus 1. Take a 1 from both sides. Minus 1 equals to minus k over 4 times 4 to both sides. Minus 4 equals to minus k, So k equals to 4. Right, so then we sub the value of k back into the equation. Therefore, y is equal to minus 4 over x plus 1. Alright, so hopefully these examples the examples I've gone through in this lesson is enough for you to have a go at these questions. Don't be too stressed if you can't do some of these, as they are really challenging. So if you have the issues, just feel free to post onto Google Classroom. Thank you for watching.